Hello class, I hope everyone is doing alright today. Today we're going to start a lesson on factoring polynomials in the form of ax squared plus bx plus c. We're going to start off by looking at the example x squared plus 8x plus 15. Looking at the form of ax squared plus bx plus c, you'll notice a is our coefficient in front of the x squared term, b is the coefficient in front of the x term, and c is our constant term. So in our example, there's no number written in front of the x squared, so it's automatically assumed to be a 1. Therefore, the value of a is 1. B is our coefficient in front of the x, and in this case, 8 appears in front of our x. And c, our constant term, is 15. In order to factor this down into the product of two binomials, I have two tools to help me with this. The first one being the x that you see in the bottom left-hand corner. In order to start filling out our x, the first thing is to find the top part, which is the value of a times c. So in this case, I'd multiply 1 times 15 to get 15. And our value of b again is 8, and that goes in the bottom part of the x. To fill in the remaining two parts of the x, I want to look for numbers that multiply to the top part and add to the bottom part. So if I'm looking for numbers that multiply to 15, I know 1 times 15 multiplies to 15, but 1 plus 15 adds to 16, not 8. 3 times 5 also multiplies to 15, and 3 plus 5 is 8. So those are our remaining two numbers that we were trying to find. So I'm going to write 3 and 5 as the remaining pair of numbers in my x. Now I can use my x to fill in my box on the bottom right-hand corner. The top left box is always our ax squared term, so in this case, just x squared. And the bottom right-hand box is our constant term, 15. The remaining two parts of the box are filled in with the two values we found in our x, the 3 and the 5, but those represent that middle term, the 8x in our polynomial, so I'm going to put an x with each of those. Now I'm going to start looking at each pair of vertical and horizontal terms in my box and find their greatest common factors. So looking at the first vertical pair of terms, x squared and 3x, their greatest common factor is x. And my other pair of vertical terms, 5x and 15, their greatest common factor is 5. Now I'm going to start looking at each pair of horizontal terms. So if I look, x squared and 5x, their greatest common factor is x. 3x and 15 have a greatest common factor of 3. Now I can use the side lengths of my box to write the two binomials that are the factors of x squared plus 8x plus 15. So looking across the top, I have x plus 5 because our 5 was positive. And then looking across the side, I have x plus 3, again because the 3 was positive. I can always check my answer by foiling this through to see if I get back to my original expression. So if I multiply x times x, I get x squared. X times 3 is 3x. Then if I distribute through the 5 times x is 5x, and 5 times 3 is 15. I can combine my two middle terms, 3x and 5x, to get 8x, so it does multiply to my original expression. Therefore, x squared plus 8x plus 15 factors into the binomials of x plus 5 and x plus 3. Now let's try looking at another example. 3x squared plus 7x minus 10. We still need to start off by identifying our a, b, and c. So a, again, is the coefficient in front of x squared, in this case 3. b is the coefficient in front of x, in this case 7, and c is our constant term, negative 10. When you're identifying a, b, and c, make sure to pay attention to the signs of the numbers. Now I'm going to start creating my x, and I'm going to start off by multiplying together my a and c. 3 times negative 10 is negative 30. That goes in the top part of the x. And the bottom part, I'm going to put my value of b, 7. Now I need to start finding values that multiply to negative 30 and add to 7. The only way to multiply to a negative number means that one of the numbers has to be negative. In this case, I would multiply together negative 3 and positive 10 to get negative 30 and add to 7. Now that I've filled out my x completely, I'm going to start filling out my box. In the top part of my box, the top left-hand box is always going to be my ax squared term. So in this case, 3x squared. The bottom right-hand box is the constant, negative 10. And the remaining two boxes are going to be filled in with those values with an x attached to them that I found in my x over here. So I'm going to have negative 3x and 10x. Now I'm going to start looking at the common factors of my vertical and horizontal pairs of numbers. 3x squared and negative 3x share a common factor of 3x. 10x and negative 10 share a common factor of 10. Now I'm going to look at my horizontal pairs of numbers. 3x squared and 10x share a common factor of x, and negative 3x squared and negative 10 don't have any common factors other than 1. Now this is where this gets a little bit different than last time. Last time we didn't need to check this, but in this time we do. Since I have negatives, the area of each of these little boxes, if I add them up together, should be the area of my entire expression that I started with. Now, to find the area of each little box, I need to multiply the length and width. So if I multiply x by 3x, it checks out. It gives me 3x squared. If I multiply this x by 10, it should be 10x. That checks out as well. But when I start looking at my boxes down here with the negatives, if I multiply 3x by 1, that gives me positive 3x. I want negative. That doesn't check out. In order to make it work, I have to make the 1 negative. Now it checks out. Then if I multiply my 10 up here by the negative 1, it gives me negative 10. It checks out. Therefore, my expression factors into the binomials of 3x plus 10 and x minus 1. Now remember, we should always check our answer by using our double distributive property. If I multiply 3x times x, I get 3x squared. 3x times negative 1 is negative 3x. Then if I distribute through the 10, I get plus 10x minus 10. I can combine those two middle terms, because they're like terms, to get 7x. So it does simplify to 3x squared plus 7x minus 10, so it checks out. So my final answer is that 3x squared plus 7x minus 10 factors into the two binomials of 3x plus 10 and x minus 1. Let's try out one last example together. So again, we need to start off by identifying our a, b, and c. So a, the coefficient in front of the x squared term, is 5. B, the coefficient in front of the x term, is negative 9. And c, our constant term, is negative 2. Now I can go to my x and start off filling out the top part by multiplying together a and c. 5 times negative 2 is negative 10. And I can fill out my bottom part of the x, b, with the value negative 9. Now I want to find numbers that multiply to negative 10 and add to negative 9. Since I have negative 10, I know one of my numbers has to be negative. In this case, after trying several pairs, I found out that negative 10 times positive 1 multiplies to negative 10 and adds to negative 9. So now I can start filling out my box. In the top left-hand box, I'm going to put my 5x squared, and the bottom right-hand box, I'm going to put my negative 2. And I'm going to fill out my remaining two boxes with the numbers I found in my x, negative 10x and 1x. Now that my box is filled out, I can start looking at the pairs of vertical and horizontal numbers and find their greatest common factor. If I look at 5x squared and negative 10x, the greatest common factor is 5x. If I look at 1x and negative 2, their only common factor is 1. Then if I look at 5x squared and 1x, their only common factor is x. And if I look at negative 10x and negative 2, their common factor is 2. Now remember, since I have negatives, I need to check out to make sure it actually works. If I multiply x by 5x, it gives me 5x squared. That checks out. If I multiply x by 1, that gives me 1x. That checks out. Now if I multiply my 2 by 5x, that gives me 10x, and I want negative 10x. So that does not check out yet. I need to make the 2 negative. Now it checks out. Then if I multiply my 1 by the negative 2, that gives me negative 2 and it checks out. So I can write my two factors as 5x plus 1 and x minus 2. Now if I use my double distributive property to multiply that out to check it, 5x times x is 5x squared. 5x times negative 2 is negative 10x. 1 times x is plus 1x. 1 times negative 2 is negative 2. Combining my like terms in the middle, negative 10x and 1x, give me the negative 9x. So it does simplify to 5x squared minus 9x minus 2. Therefore, I know that the trinomial 5x squared minus 9x minus 2 factors into 5x plus 1 times the quantity of x minus 2. I hope this was helpful. Let me know if you have any questions.